All right, hello everybody. This is Miss Pie again, and I am once again out of the classroom. I'm still helping with Challenge Day, but I will be back tomorrow. So hopefully you will, hopefully you're doing these worksheets and getting them turned in, or else you're going to have a lot of work to make up when you get back, or when I get back. All right, so let's look at this worksheet, the binomial probability problems. I will go over what binomial probabilities are probably tomorrow and the next day. Let's look at some examples. We've already done things like this before, so it shouldn't be too hard. And then when I get back into the classroom, we'll start looking at all the different formulas and how we get binomials. All right, so let's look at problem number 1. I'm going to walk you guys through all of this together. And then for problem number 2, you need to work on that on your own or with your group. And this worksheet is due at the end of class, so don't waste your time on this. All right, so we have, for problem number 1, we have a family that has 3 children, and use the tree diagram below to list all 8 possible birth orders in terms of whether each child is a boy or a girl. All right, so for the first kid, their options are they can have a girl or a boy. Okay, not too complicated there. For their second kid, if they have a girl, they can have another girl, or they can have a boy. Again, still very simple. If they have a boy first, then for the second kid, they can have either a girl or a boy. And then for their last child, the third child, they can again have either a girl or a boy, girl or a boy, girl or a boy, girl or a boy. All right. So these are all the different combinations, and in this one, on this path here, or this branch here, you're going to have a girl, girl, girl. Let me make this smaller letter so I can fit all these in. And, oh, sorry guys. Okay. The next branch, they have 2 girls and then a boy, and then a girl, a boy, and a girl, and then a girl and 2 boys. Let me give myself some more space here. There we go. And then in this branch, a boy and 2 girls. Let me make this smaller. Let me do it even smaller than that. There we go. And then in this one, they have a boy, a girl, and a boy. Let me make this. Sorry, guys. I know I'm picky. I probably should have gotten this organized earlier. That's okay. All right, so boy, girl, girl, boy, girl, boy, and then a boy, boy, and a girl. And then the last one, all 3 boys. All right, so this is what we have. These are the different combinations. And let's go ahead and look at A and B and answer these. Of the given orders of children, how many contain no girls? All right, so the number, there's only 1 down here that have no girls, right? So let me see if I put the answers up here. No, I didn't. I thought I did. All right, sorry. All right, so right here we only have 1 combination that has no girls. And then how many have 1 girl? Well, right here I just have 1 girl. Right here I have 1 girl. Here I have 1 girl. And that's it. Okay, so this time we have 3 of them that have just 1 girl. How many have exactly 2 girls? Okay, let me erase those. Let's see how many have 2 girls. So let's see. Here's one with 2 girls. Here's one with 2 girls. And then here's the last one with 2 girls. So we have, again, we have 3 of them that have 2 girls. And then how many have all girls? Well, with that one, it's just this one has all girls, so just 1. All right, so that's what we've got so far. Let's look at problem B. Complete the chart to show each probability for a set, excuse me, of 3 children born to a family. Excuse me. So this is somewhat of a review from our last unit. What's the probability of having no girls in a family? Well, they can have all these different combinations, and there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different outcomes. Okay, you need to know how many different outcomes there are. So there's 8 different outcomes. Okay, of those 8 outcomes, how many have no girls? Up here we already looked at it, we just said 1. So with this, we have 1 out of 8 or 0.125. If you were going to convert that to a percent, because with probabilities you can write it as a fraction, you can write it as a decimal or a percent. If you change that to a percent, it would be 12.5%. Okay? So any couple that has 3 children, they have a 12.5% chance of having no girls. Okay? And then what's the probability of having 1 girl? Well, up here we said there were 3 different options that contained 1 girl, and there's out of 8 outcomes. So it would be 3 out of 8. Whoops. Hold on. There it is. I'm uncovering the whole bunch of stuff I shouldn't uncover yet. Sorry. Pretend you don't see this yet. All right, so in this outcome, we have 3 out of 8, or 0.37 of the probabilities. Okay, convert that to a percentage, it would be 37.5%. Okay. Make sure, I would like to see every single one of these on your paper. Write it as a fraction, write it as a decimal, and convert that decimal into a percent. Remember, if you are typing these into your calculator, you'd have to do 1 divided by 8. Instead of just pushing equal, push control equals, and it will give you a decimal. Okay? And then, so the probability of having exactly 2 girls, again, we have 3 out of 8. And so it's going to be 0.375 or 37.5%. And then the probability of having 3 girls, well, 1 out of those 8 options. So again, 1 out of 8 or 0.125 or 12.5%. All right. Now, if you add up all of those probabilities, so probability of having no girls, 1 girl or 2 girls, or all 3 girls, then go ahead and add these decimals all together in your calculator. You should get 1 as your answer. Okay? The reason why you have a total of 1, or the total probability of 1, is because you have calculated the probability of each type of result. Okay, now notice there's lots of different combinations here, lots of different orders on the birth, but we don't care about the order. We just want to know what's the likelihood of having 2 girls, 1 girl, or 3 girls, or no girls. Okay, and we've covered all the different types of outcomes. Okay, so when you are explaining for Part D, explain the reasoning for the total of probabilities, you have, if you've covered all possible options, okay, if all probabilities are acceptable, there is a 100% chance of the event occurring. Okay, so if you don't care whether you have a boy or a girl, you have a 100% chance of being satisfied if you have 3 kids, right? So I know this doesn't give very much explanation of what you're doing, but basically you need to know if you add these all up and you get a 1, then you've covered all possible outcomes. Okay. So in this case, what if we didn't have we didn't look for the probability of having 3 girls? Then we would not get a 1 here, and we would know that we were missing one possible outcome. Okay. All right, so let's look at part 2. Well, real quick, I can't remember if I included part C on this problem. Do not worry about part C. We are not going to do it at all. Okay, if it's still on the worksheet, just cross it off. All right, so let's look at part 2. With this one, we are flipping coins. And we're going to flip the coin 4 times, and we have if we flip it once, we might get a head. The coin might land on heads, excuse me, or it could land on tails. Okay, so the first time we flip the coin, we don't know if it's going to land on heads or tails. I absolutely love this application. I found it on this. It's pretty cool. So in this case, I got tails, tails, head, and tails. Okay. So in this box, I could list that outcome. We had tails, tails, head, tails, right? Well, in this case, I want to know, as I'm flipping this coin 4 times, what are my options? And now here, we are gonna list the different outcomes, whether it's heads first, second, third, or tails fourth. Okay, so those are all different. I'm going to show you a couple of the different combinations. I'm not going to show them all to you. You've got to find the rest, the other possible outcomes. Okay, so there's a few of them. All right, so in this case, notice they start out getting heads every single time, have the coin land on heads 3 times, and then having it land on tails. And notice here, we're just changing from here to here, you're changing where the coin is landing on tails. Okay, there's lots of different combinations. It may be difficult finding all 16 combinations. Check very carefully, make sure you're not repeating, and make sure you're not missing any. I will tell you at the very end here, you're going to have the outcome of landing on getting tails all 4 times that you flip the coin. Okay, go ahead and fill out this table, then find all the possibilities, or then look at these, see how many of them have all heads, 3 heads, 2 heads, 1 head, and 0 heads. So answer the rest of the problems very similar to what we did for problem number 1. And let's see, yeah, I think that's all you have to do on this worksheet. I am going to have the sub pause this movie pause the video for about 5-10 minutes, give you time to work on this, and then move on to the next worksheet. I just want you guys to get started on it. It is a little bit complicated and time consuming, so I want you to do the first problem on this next worksheet, and we'll finish it up Thursday and Friday. Okay, so please pause this, give the students about 5 minutes. Once most of them are done, go ahead and start it again. And then once you finish the video, you can stop it and either rewind it or just give the students time to finish up this worksheet. So this worksheet needs to be turned in by the end of the class. The next one that you get started on, you don't have to turn it in at the end of class. Just keep it with you, bring it tomorrow, we will work on it tomorrow. All right, so go ahead and pause it and then start it again in about 5-10 minutes. All right, so let's look at this worksheet. We have a baseball batting contest, and the organizers have set up game booths for the contestants. Richard wants to win a large stuffed animal. So the rules of the game are as follows. Richard is going to be pitched 5 fastballs, and he has to hit them into a fair zone to count. And then if he's successful with hitting all 5 pitches, he will win the stuffed animal. If he only hits 3 or 4 pitches, he will get a small stuffed animal. If he only hits 1 or 2 pitches, a bat-shaped pencil. That sounds super exciting. If he misses all of them, he doesn't get any prize. So no prize at all if he misses them all. And then the game costs $3 to play, each set of 5 fastballs. All right, so for problem number 1, they want you to, what are the possible outcomes that Richard can have on his 5 swings? Explain or show how you arrived at this answer. I'm going to change that direction to explain and show how you arrived at that answer. You might have to get a separate sheet of paper to set up a tree diagram. So for his first pitch, the possible outcomes are he can hit the ball or he can miss it. So in this case, a hit, H stands for hitting the ball, M stands for missing the ball. That's supposed to be a 1 there. So that's for his first pitch. If he hits the ball the first time, for his second pitch, on the second pitch, he can either hit the ball or miss it. If he misses the ball the first time, for the second pitch, he can hit the ball or miss it. Okay, and so on. And I want you to create a tree diagram for every single pitch. Okay, so go ahead and finish this problem and then work on finishing up the rest of the worksheet, and I will see you guys tomorrow.